All right, let's look at the two for your turn. At the start of a snowstorm, it snowed 2 inches an hour for 2 hours. Then it slowed to 1 inch an hour for an additional hour before stopping. 3 hours after the snow stopped, it began to melt at 1/2 an inch an hour for 2 hours. All right, and then the other one says a local salesman is going door to door trying to sell vacuums. For every vacuum he sells, he makes $20, and he can sell a maximum of 10 vacuums a day. All right, so the first thing I want you to kind of do is think about the situation. Should this situation be a discrete graph, meaning points that aren't connected, or should it be a continuous graph? And then it also asks you to determine what the domain and range is. Remember, the domain is your set of x values, your range is your set of y values. Okay? So let's take a look at what we got. Oh, it's like magic. It's right there. The snowstorm. That is a good example of, that's not your bell, so don't get excited. That's an example of something that would be suitable for a continuous graph because the snow is gradually going to accumulate. So pink part, 2 inches an hour for 2 hours, then 1 inch an hour for an additional hour, then it stopped, and then it started to melt. Okay? Best represented by a continuous graph. Your domain is your set of x values, which is from 0 to 8 hours. Your range is your set of y values, which is from 0 to 5 inches because you accumulated 5 inches. All right, the one with the vacuum cleaner should be a discrete graph because think about it, you can't sell a half of a vacuum or a fourth of a vacuum or anything like that. Okay? Your domain is your set of x values. Remember in the problem it says he can sell a maximum of 10 vacuums a day, so your domain is from 0 to 10. Your range is the possible amount of money he can make, and that's anywhere from 0 if he sells 0 vacuums, all the way up to 200 if he sells all 10 vacuums. Okay? All right, and then let's hop over and look at the questions real quickly on the other page, 101, where it says elaborate. Okay, when interpreting graphs of real-world situations, what can the slope of each part tell you about the situation? It tells you the rate at which things are changing, okay? If it's distance versus time, it tells you how fast the distance is changing as time goes by, that kind of thing, okay? What is the best way to sketch the graph of a situation? Ha ha, I would say pencil if you mess up, but that's not really what they want. Okay, number 9, how can you tell when to use a discrete graph as opposed to using a continuous graph? Give an example of each. Okay, basically ask yourself this question. Is it reasonable for you to have parts or fractions of an item, or is it not reasonable? If you can have something like a part or a fraction or a tenth or just a teeny weeny piece of it, then maybe continuous makes sense. If you can't have fractions or parts of something, then discrete needs to be your answer. Okay? So on the previous page, continuous made sense for the accumulation of snowfall. Discrete makes sense for the number of vacuums sold.